here. We got, what is going on here? Files in use. I don't know what's going on. All right, let's try that again. We are working on our Unit 8 test review, right? This is page 4. Looks like we got a lot of graphing going on here. So let's get to it. All right. We need to give the best name. All right. So when we graph these things, we have to classify them. So like think of the best name. So if I see a dog or something, right, I could say, oh, there's a dog. But if I want to be more specific, I could say like, oh, there's a Dalmatian or something, right? So I want to be as specific as I can with this quadrilateral, right? There's a bunch of quadrilaterals that we have talked about this unit. So we just have to give the most specific name for it. So the first things first, graph your points. All right, carefully plot your points here. So I got -1, 4. We're gonna go right here. We're gonna have, I got 2, 6. 1, 2, 3, 4, 5, 6 up top. 3, 3. It's gonna go right here. And then 0, 1, 0 to the right, 1 space up. And I think that looks good. All right, so this is point F, A, R, and T. All right. So plotting these points, we have to think, what does this shape look like? Oh, let me try that again. What does this shape look like? Well, first, right off the bat, I don't know, to me it looks like a parallelogram, right? It doesn't look like a square, doesn't look like a kite, doesn't look like a trapezoid. So we are just going to confirm that. So what we did this time in I don't know what I'm trying to say. Sorry. We're looking at the diagonals. All right, so I'm going to look at FR. All right, so FR. All right, what is the midpoint of FR? The midpoint, I'm just going to say the x coordinate on the midpoint using point F and point R. I got -1 plus 3 over 2. -1 plus 3 is 2. Divided by 2 gives us a 1. All right, so FR has an x coordinate of 1 and the y coordinate, same idea, 4 plus 3 divided by 2. That's going to give us 3.5. All right, so we have a decimal, not a big deal, whatever. All right, so that is the midpoint of FR, sorry. I got 1 and 3.5. All right. Now, I did a little bit different in class. I'm just going to stick with FR for now. So I'm going to find the slope of FR now. So the slope of FR, all right, is going to be equal to, we have a rise over a run. So y2 minus y1. So I got 3 minus 4 over, let's see here, FR. So I started with R, I went to F. So 3 minus -1. All right, so that's going to give me -1 over 4. All right, so the slope of FR is -1/4. All right, now I'm going to find the distance. All right, how long is FR? And I'm going to use the distance formula on this one. So again, using point F and point R, I'm going to have 3 minus -1, all right, squared. All right, plus, and I'm going to do the same thing with the y's, so 3 minus 4. We're going to go ahead and square all of that. All right, 3 plus 1 is 4. 4 squared is 16. 3 minus 4 is -1. Squared is +1. So this equals the square root of 17. All right, so all of that work that I just did told me the slope of FR, the midpoint of FR, and the length of FR. All right, now I'm going to do the same thing, but with AT. All right, so I'm going to find that diagonal. All right, so I'm going to start with AT. I'm going to go in the same order, so let's find the midpoint. So the x midpoint is equal to, now we're using point A and point T. All right, so just very carefully use the points that are listed. The x midpoint here is going to be 2 plus 0 divided by 2, which equals 1. All right, the y midpoint is going to be 6 plus 1, divided by 2, which gives us 3.5. All right, so our midpoint here is 1 and 3.5. All right, now let's find the slope. All right, so again, the slope of AT. Slope of AT, same idea. So y is on top, x is on the bottom. 1 minus 6 over 0 minus 2. That's going to give us a negative 5 over negative 2, which is positive 5 halves. All right, so there's your slope of AT. Now the last thing I'm going to do is we're going to do the distance formula on AT. So 0 minus 2 squared plus 1 minus 6 squared. Negative 2 squared is 4. That's going to give me negative 5 squared is 25. 25. This is square root of 29. All right. So that was a lot of work. All right, admittedly, but get over it. That's what we have to do. This is everything that we can use to classify what this shape is. All right. So the first thing I'm going to look at are the midpoints. All right, the midpoint is 1 comma 3.5 on both of these shapes. All right, so that tells me the diagonals bisect one another. All right, so that tells me it is at least a parallelogram. All right, so that's a possibility. All right, so we've eliminated a kite, we've eliminated a trapezoid, and we've eliminated an isosceles trapezoid. All right, now we just have to eliminate the other ones. All right, so if I look at the slopes, all right, the slope of FR is negative 1/4. The slope of AT is positive 5 halves. Okay, that tells me that FR is not perpendicular to AT. I remember perpendicular lines have to have opposite and reciprocal slopes. All right. So since those lines are not perpendicular, we have eliminated the rhombus. All right. So it's not a rhombus. If it's not a rhombus, it can't be a square. So square is out. All right. And then the last one we need to check for is the rectangle. And that one, we have to look at the lengths of the diagonals. In order for this to be classified as a rectangle, the diagonals need to be congruent. Well, if you look at what we just did, we use the distance formula to find the lengths of them. All right, and we know that FR is not congruent to AT. So we have eliminated the rectangle. All right, so I'm going to cross that one out. So the best thing we can classify this as is a parallelogram. All right, it is not any of those three. All right, it's not a rhombus because the diagonals are not perpendicular. It's not a square because the diagonals are not perpendicular. It's not a rectangle because the diagonals are not congruent. Okay, so all of this work here is all of your justification. All right, so on all of these problems, right, just focus on the diagonals. All right, you got to do 6 different things, which does take a little bit of time, but it's very procedure based. All right, find the midpoints of each one, find the slopes of each one, and find the lengths of each one. All right, and then if you understand your properties, right, then that is going to help you eliminate it. All right, so that's my piece of advice on this one. Just know all the properties, know these 3 formulas. I'll give you a formula sheet for the formulas, but just know all the properties. All right, I have a feeling this is going to be the same thing. Give the best name for this quadrilateral. All right, take 2. So you got negative 2, 2. All right, you got 0, negative 2, 6, 1, 2, 3, 4, 5, 6, 1, and 4, 5. All right, so same thing here. All right, let me throw some letters on here. We had Q. We have R. This is S and T. All right, so let's do it all again. I'm going to find QS. All right, so this is going to be a longer video. QS, I got the X midpoint is equal to, I'm going to go a little bit faster on this one, -2 plus 6 divided by 2 is going to give us a 2. All right, the Y midpoint is going to equal, we got 2 plus 1 divided by 2, which gives us 1.5. All right, so that midpoint to 1.5. All right, the slope of QS. All right, we have a graph. Let's take a little bit of a shortcut here. Let's just figure out, remember, slope is rise over run. So how many spaces down are we going? How many spaces to the right are we going? All right, so you could use the slope formula, or you just count the spaces. So it looks like we're going down 1. So I'm going to put -1, and then we're going to the right. 1, 2, 3, 4, 5, 6, 7, 8. 8 spaces. So -1/8. All right, so just count the spaces. That'll save you a little bit of time. All right, and then the length of QS is going to be equal to, again, we could plug this into the distance formula. We could, there are a couple of other shortcuts. So you could, if you look at the slope, the unreduced slope, right? Sometimes we reduce it. I'm just going to call this -1 squared plus 8 squared. All right, this is going to give us a square root of 65. All right, so there's all three things on QS. Now let's find RT. All right, so got blue ink on R and T. So the X midpoint, 0 plus 4 divided by 2 gives us 2. The Y midpoint is equal to -2 plus 5 divided by 2, which gives us 1.5. All right, so looking at that, we automatically know it's a parallelogram. Look at those midpoints. They are the same, right? Anytime you have the midpoints that are the same, they bisect each other, right? So we automatically know from that that this is a parallelogram. All right, now the slope of RT, the next one, it's your rise over your run, starting at R, going to T. We're going to go up 1, 2, 3, 4, 5, 6, 7. 2, 3, 4. All right, so you get 7/4. All right, so again, those slopes are not opposite nor reciprocal. All right, so those are not going to be perpendicular. Therefore, it's not a square. It's not a rhombus. All right, so square and rhombus are out. And the last one, we got to figure out the length of RT. All right, RT is equal to, I'm going to do 7 squared plus 4 squared. 49 plus 16, 49 plus 16, that's 59, that's a 65. All right, so the diagonals are congruent. All right, so I'm going to say RT is congruent to QS. All right, so this means it's a rectangle. All right. I'm going to say RT is not perpendicular to QS, so it's not square. And I'm going to say not rhombus. All right, I ran out of room there. So we're abbreviating. We're sloppily abbreviating that one. Let me try that again. All right, it's not a rhombus. All right, that one's done. So this one's a rectangle. All right, I think I got one more here. Find the perimeter and area of the given polygon. All right, so I don't know what shape it is. All right, it doesn't say it's parallelogram or anything. I just know it's a polygon. All right, so it's got 4 sides. That's all I know because it's got 4 letters. One to the right, three up. It's gonna go right here. I got two to the right, one up. I have -2, so two to the left, one down. Gonna go right there, and then -3, one. All right, so what does this shape look like? All right, this one, this is a rectangle. So here, let me, and I know it's rectangle. I'm just gonna, let me label this. I got A, B, C, and D. All right, let's see. I'm gonna say slope of dA, slope of dA, we're going up two to the right four. So that's 2/4, which is 1/2. All right, the slope of CB is also 2/4. All right. So the opposite sides are parallel. So we got DA is parallel to CB. All right. I'm going to say the slope of, how about DC? That one is -2/1. I'm going to say the slope of AB, it's also -2/1. So I know that DC is parallel to AB. Right? Therefore, I know it is a parallelogram. All right. If I write opposite sides are parallel, but if I look at these two, those are opposite reciprocals. So I can say CB is perpendicular to DC. All right. So I need to figure out the length of DC. I need to figure out the length of CB. I need to multiply them together. That'll give me the area. All right. So let's do that one real quick. DC is square root of, I'm going to use point D and C here. -3 plus 2. I'm taking a shortcut here. This video is getting a little long. At -3 plus 2, and then we're going to have 1 plus 1 squared. Let's see. That's going to be -1 squared is +1. 2 squared is 4, so this is the square root of 5. All right. So I know DC is the square root of 5. Therefore, I know AB is also the square root of 5, right? Because the opposite sides are congruent. All right. Let's see here. I'm going to find AD. All right, so now I'm using points A, B, C. Oh, we're good. We're good. Okay. -3 minus 1 squared. And then we got 1 minus 3 squared. -1 minus 1 is -4 squared is 16. All right. 1 minus 3 is -2. -2 squared is 4. 16 plus 4 is 20. This is the square root of 20, which of course simplifies down to 2 times the square root of 5. That means BC is also 2 times the square root of 5. All right. So from here, we know the perimeter, right? All the sides added together, the perimeter is equal to square root of 5 plus square root of 5 plus 2, square root of 5 plus 2, square root of 5. How many square roots of 5 do you see? I see 6 of them. Right? So this is 6 square root of 5. All right. Now the area is equal to the base times the height. All right, so the base and height just have to be perpendicular. So this is going to be 2 square root of 5 times the square root of 5. Square root of 5 times square root of 5 is normal 5. So we have 2 times 5, which gives you a 10. All right, so if you wanted to think about it, this piece right here, you could think of that as the height. You could think of that as your base. Those are perpendicular. We know they're perpendicular because of this guy right here. Those are opposite reciprocal slopes. All right, so we can just multiply those together. We have an area of 10. All right. Oh, so there we go. That was kind of a longer page, but we only have one more. All right, so I will see you guys in the next video. And we'll go from there.